Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to our panel, TS Dr. Muhammad Hafiz bin Muhammad Noor, and also to TS Dr. Zurriati Binti Muhammad Ali. I am Ahmad Hafizuddin bin Anuar, student from School of Mechanical Engineering UiTM Shah Alam, and today I would like to present my final year project proposal, which entitled The Study of Structural Integrity of Generating Tube Under Fluctuations of Heat Transfer. This project is supervised by TS Dr. Zainoor Hailmee bin Solihin. To summarize this whole project, I will go with three important key points. Firstly, the generating tube of a waste heat steam boiler is focused on as the structure is exposed to fluctuations of heat transfer. Most of modern industrial sectors require steam as part of their energy sources. This is because steam is the most abundant as well as a renewable type of energy. In converting steam into an energy source, the process of high temperature and high pressure is needed. Therefore, from time to time, this condition would cause several damage mechanisms to the downcomer structure, such as steam cut. I propose that a specific design of downcomer is sketched onto a CAD software, which is CATIA V5 program. From this modeling of downcomer structure in the CAD software, the analysis of the structure can also be done into computational fluid dynamics, CFD, which then is an ANSYS Fluent 18.1. The parameters that are desired throughout this analysis is fluid velocity, thermal conditions, and stiffness. Moving next is the introduction to this project. What makes this project interesting? Actually, the design of the steam drum itself is very unique because it connects from another boiler towards another waste heat boiler, or also known as heat exchanger. The downcomer part of the boiler's design will supply water to the shell side of the waste heat boiler. This saturated liquid will flow through the downcomer by the effect of gravitational force. Under fluctuations of heat transfer would also provide temperature difference across the thickness of the pipe. This will yet pursue another mechanism, which is thermally induced stress. Previous study of journals and articles brings out the literature review to this project. On his paper of an experimental investigation of flow bearing instability in a natural circulation loop by Chen, proposed that instability of flow in boiling process could produce dynamic interactions in between compressible volume and heated channel over time. Moreover, on a paper of numerical study of flow boiling in an intermediate scale vertical tube under low heat flux by Yin, the simulation that they made by the 5-meter long tube stainless steel bring up the values of fluid saturated temperature at 110 degrees Celsius with average heat transfer coefficient of 3729.39 watt per meter squared Kelvin. These results were actually not in par with the study of Foster and Zuber saturated nuclear flow boiling relationship. Further analysis stated that this difference is due to the flow boiling under different conditions, such as of its tube length, tube diameter, heat flux, inlet velocity, outlet velocity, and so on. And moreover, the study by Tit Selling on his paper of fluid structure interaction and cavitation in a single elbow pipe system proposed that a piping having a material of linearly elastic would undergo small deformation. Lastly, on a paper of high accuracy CFD prediction methods for fluid and structure temperature fluctuations at T-junctions for thermal fatigue evaluation by Kian, stated that at T-junction, the usual damage mechanism found over there is thermal fatigue failure due to the mixing of hot and cold fluids. The readily conventional method of finite element analysis, FEA, tend to provide imprecision. Therefore, Kian suggested that the combination of FEA and CFD coupling analysis would provide more accurate data of evaluating the thermal fatigue at T-junction. The problem statement and objectives of this research are as follows. First, the problem statement. By steady state of rate of liquid feed, the steam drum outlet flow of steam is equal to the steam produced by the riser tubes. Under continuous exposure of the steam outlet flow, also known as the downcomer structure, the pipes wall, especially near the elbow, might experience diffraction. Therefore, a basic approach from derivation of Navier-Stokes equations and proper modeling of the two-phase region are needed. Hence, the objectives of the study are as follows. First, to construct a proper design of an industrial downcomer through a CAD software chosen, which is CATIA V5 program. Next, to analyze the structural integrity of the downcomer tube by consideration of CFD software and Fluid, as well as analyzing the temperature profile, the velocity streamlines, structure total deformation, equivalent von Mises stress, and equivalent elastic strain. With that being said, let's move on to the scope and limitations of this project. The first scope of the project is to have the desired outcome of analyzing the structural integrity of the downcomer by consideration of governing equation derivation. Moving next is by having the simulation analysis, the life expectancy of the downcomer tube could be estimated until the point of failure under steam saturated liquid processes. Next is the limitations of this project. I found out there are 3 limitations during this research, which is the first one, insufficient data and information archives. Next, computer mid-range setup causing limitation towards the CFD software analysis, such as iterations and meshing processes. And lastly, due to the COVID-19 pandemic outbreak restrictions, we have limited resources and time. By having the study of structural integrity of generating tube under fluctuations of heat transfer, hopefully it will provide vital insights to industrial sector in maintaining and inspecting the downcomer structure. Also, the study hopes to bring up the utilization of CFD software in various industrial background purposes in relationship with fluid flow and heat transfer process. As shown in the flowchart, these are the methodology that is used in this project. In the first phase, the structural integrity of the downcomer study initiative, and next, the phase of previous journals and article reviews from previous studies, and also the computation of mathematical model and governing equation following to the modeling and meshing of downcomer structure on CAD and CFD software respectively. As soon as modeling and meshing of this downcomer structure, the simulation is then analyzed on the CFD software. Whether the outcome is the desired or not will determine the data analysis and reporting carried out, and as upon this data analysis and reporting marks the end of this project. Otherwise, the modeling and meshing of this downcomer structure will be revised, and the simulation on the CFD software will be carried out once again. Throughout the methodology, I would like to emphasize on the FBD construction, the modeling and CATIA V5, as well as the meshing process in ANSYS 18.1. Free body diagram, as shown in figure, is required in order to identify the related parameters as well as the governing equation. Generally, from the pressure exerted due to fluid flow, the wall of the pipe is exposed to deflection as consequence of distributed load. Furthermore, the parameters are considered through the study are: first, operating pressure; next, operating temperature; the third one is boiler rated liquid capacity; and lastly, the fluid velocity itself. Referring to the earlier free body diagram, the downcomer structure will be designed in the CAD software accordingly with its dimension as per industrial use. Later on, the design will be imported into the ANSYS design modeler, whereas the inlet and outlet will also be specified in the meshing process. The nodes and elements for meshing process was proposed to be at value of 72,000 until 200,000 and not exceeding 1 million respectively. Upon completion of meshing and iteration process in the CFD software ANSYS Fluid, the preliminary results of temperature control and velocity streamlines of the downcomer structure could be computed out. Nevertheless, the nodes and elements of the structure would be improvised for further and better analysis for the study of structural integrity of the generating tube under the fluctuations of heat transfer towards the end of the study. And these are the list of references. That's all about it for my presentation, I suppose. Thank you for your time and attention. If you have any inquiries, feel free to let me know through phone or email. Assalamualaikum warahmatullahi wabarakatuh.